Hi everyone, I am Prototype Guy and welcome to the third episode about the Electro sub-project. In this episode I will tell you about the current status of this project and upcoming changes. Let's get started. This video is divided into a few parts, which you can see on the screen right now. You probably spotted this black case in the middle. This is the most important part of this project. It holds battery, ESCs, computer and other stuff. Here is the main board, which is the brain of this whole system. It's based on ESP32 dev board and also has a step down which turns 5 volts into 3.3 volts for the ESP. There are also some gold pin outputs. These two are for the buttons up here. This one is for the pilot and this connects to servos in the propulsion modules and these control the ESCs. On the bottom here is a lithium-ion battery pack. It's a 4S 3P setup, so it outputs around 15 volts and can provide 30 amps, which is also the limit of the BMS. The output is a standard XT60 connector. The next to the pack is a board, which serves as a power distribution board. It takes one input from the battery and turns it into two outputs for the ESCs. It also has two current sensors, one for each ESC, and a step down, which turns 15 volts into 5 volts and powers the main board. Here used to be two ESCs, but one was removed during the tests and now there's only one, enclosed in this box. And the purpose of it is to hold the cooling oil inside. Yes, I decided to use oil cooling in this project, which turned out to be a terrible idea, but more on that later. Okay, now I will tell you a little bit about the pilot itself. And as you can see, it's in a pretty rough shape. That's because it went through a lot of pain during the testing and I made a lot of changes to it during the testing, and that's why, it's cracked and there are a lot of holes and visible damage to it. But yeah, the general design probably won't change, and so I can walk you through what is what and how it's supposed to work. So the main part is this joystick here, which is used to control the board. As you can imagine, the forward, we go forward, backward, we go backward, left and right, pretty simple. Here are two buttons, which are multi-purpose buttons. This one will probably be used for changing the modes, and this one for some other functions. They are not defined yet. And here is the third part. This is the screen, which right now shows the position of the joystick and a few other data for debugging. Yeah, so that's it. Okay, so we're moving to the tests and results section, in which I will take every single part of this project and tell you about what went wrong, what was okay, and generally how it performed. Starting with the propulsion module. It generally worked okay, servos survived a long exposure to salty water and there were no problems with turning the module. Motor worked great as well, and the only part that caused problems were the bearings, which rusted and got stuck a few times. Second part is the pilot, which worked okay and failed at the same time. It worked okay in terms of being a good and ergonomic way to steer the board, but failed due to salty water getting inside and damaging the screen and potentiometers of the joystick. However, the water got inside because of the holes and cracks that I made during the modifications, so it wasn't a design flaw, and therefore I would say that the pilot worked generally okay, and therefore I will stay with this design for now. The overall exterior, so layout of the buttons and connectors, turned out to work pretty well, and it was easy to use, so it's gonna stay this way. The same thing with the main board. It worked perfectly fine and was easy to modify if necessary. Now, ESCs themselves worked okay, but my way of cooling them with oil was terrible. The oil leaked through the boxes and was really hard to clean up. The power distribution board worked just as it was supposed to, and the battery pack was okay, except the fact that I used 30 amp BMS with it, which didn't leave any room for any additional current draw and cut the power every time the limit was exceeded. And that's it for every part of this project, and I left the biggest problem for the end. It's not connected with any particular component, but with the whole project. Two motors, each 225 watts of power, simply aren't enough to accelerate this board to a decent speed. And you can tell that by looking at this video where I use maximum power As you can see, it's pretty slow. And the third part of this video, which is about future changes to this project, starting with the biggest problem that I mentioned. A solution to lack of power is obviously more power, which is going to be provided by two of these Turnigy motors, 1800 watts each. To be more specific, this is Turnigy XK3674 and it has a kV of 1650 and it can take up to 61 amps of current. Switching to a different motor means that the whole upper part of the propulsion module would have to be redesigned. And I also decided that with so much power I don't want to rely on plastic 3D printed shafts and propellers. So I ordered some typical shafts, couplers and propellers from AliExpress. And I will test them in a similar way that I tested different propellers in the beginning of this project. To control bigger motors I need more powerful ESCs. And for the test, I will be using these APD 80 amp ESCs, which should work without any problem and with some reserve of power. In order to cool them, I won't be using oil, but instead I will order a laser cut plate of steel, lay it down on the bottom of the case and make a really big radiator with great heat capacity. And going further, more powerful ESCs also need more power, which current battery pack won't be able to provide. And I'm pretty sure that in the final design I will use lithium-ion battery pack due to its energy density and customizability. But for the tests I will be using a small LiPo battery. Why? Because LiPos can provide much more current with a smaller battery and therefore lower cost. And for around 25 bucks I can get a sufficient LiPo for testing. In terms of smaller changes, I would have to use a different connectors for the motors, because these are rated for 15 amps, so they probably won't survive with the new powertrain. And also one person suggested me that it would be a great idea to add a second way of steering the board, which is app on the phone. It would allow to steer the board from the distance and use it in case something bad happened to the pilot. But that's not the priority right now. And yeah, that's it for this video. Hope you enjoyed and see you in the next one.